Not before.
Okay. You're saying there's two, and then realized I forgot to hit record.
Yeah, my understanding, I should say, is there's two main types that are quite different. One is like called pretty much like dynamic recursive,
Yep.
which means you start with a base year
And then you
of
iterate.
calibrated data, and then you iterate and generate. Okay, if this happened that year, and you take some parts forward. I don't use the right language, I should, but um, then the next year will be based on that but different, and so forth and so forth. So recursively. And then there's the sort of full optimization where you just have an optimization over all years. What's that called?
Like a Ramsey model, like a
Um,
one-shot Ramsey model.
is that what I thought a Ramsey model was? Just the general growth kind of structure of it, not necessarily solving all at once. Maybe it is called that.
Um, I mean, it can be interpreted that way, but the ones that I've seen that are like that are primarily Ramsey models.
Mm. Yeah, so and I think with that you can have like an agent that sort of has infinite foresight, but you can also
Yep.
just, I think, optimize over any aspect, right? Like it doesn't have to be lifetime income, or that. I think that's quite common.
Yeah. This model's looking at lifetime utility, like
Yeah.
infinite utility, and then you like pin the tail.
So that's the second type, and we probably should have the language to know what they're called, but yeah.
And it is thinking about it. So what I've done, I have a very simple model. I like to print this one because you can actually just see the whole thing
Great.
outright.
Yeah, it's nice and small.
And it's just the base year calculation. So I just
Why
set up
is
a little
capital
model
negative?
right here. It acts as a negative endowment. That's a thing.
Sure. Negative endowment, trying to think about that. So you're bringing labor in, but you owe money on capital at
Yeah,
the
it's like
start,
a
in the
demand
starting.
that's not actually being demanded.
Well, you actually owe it.
Yeah.
It's a debt.
Yeah. You know, something kind of cool I found about this model. Here's the benchmark.
Yeah.
Here's with a 10% tax. Top, bottom. This threw me for a loop for quite a while because they're the same.
Yeah.
And like this had no solution. So I was like, what in the hell is happening? I finally realized this one has 1.1. All it did was raise the value of capital. A 10% tax raised the value of capital by 10%, and
Mm.
everything else was fine.
And that's because the quantity, is that because of the
I don't know.
negative endowment?
No, I think it's because the tax only applies here, and there's only one, like all you have to do is just PK, and everything else sort of balances out.
Yeah. So the tax is, wait,
Interesting.
an output. Where are we at? It's an input tax. An input tax on Y.
GAMS gets a different solution than this by default, but if I pin the solution to be what I want it to be, then it actually works.
What do you think the difference is in the default then?
Um, I don't know. I'll explore it. And they may be the same solution and you just have to like fix something.
Right.
Yeah. Yeah, but I thought it was kind of cool. But what we want to do is we want to take this data, we want to take this little model here, and we want to expand it into all years, right? And
Right.
expand it into for 2000 up to 2100. I have this here. Yeah. So it's this social accounting matrix. I'll just point at this as I go because it'll be a little bit easier. And to write our dynamic model, we need this for every year between now and whenever we want to stop. So the way that we do it, assume all quantities grow at growth rate G and present value prices decay at some interest rate R, because then quantities are given by this, reference prices are given by this. It's just compound interest decay. Okay, and then this is the important one. So this is our new, or this should be our new SAM. The T's iterate over every year. the FDs are constant, or there's just one representative agent. So this one you have to be
final demand over all time utility.
Yep. There's only one representative agent that exists throughout all of time.
Right.
So you have to be a little bit careful with this. So the rows should all add up to 0 pretty obviously. This one looks a little iffy. I'm worried that I have it wrong, but I don't think I do. And the column should add to 0, but like in particular, this one, this may not add to 0 if you just add up the numbers. And the reason for that is that the prices have initial quantities, or the prices have initial values. So these don't benchmark value at 1. These benchmark value at PREF. So over time, those prices are decreasing. So we set a start value. Except for the capital, which is offset just a little bit. It's 1 plus R. So here, let me show you what it looks like as a model. Go away. This is the scalar one. Here it is. Yeah, so here's the whole thing. So as you see, PY is pointing at in I. Output gives the capital of next year.
Oh, I see. So that's capital formation block, basically.
Yep.
Or is that true for all?
This one's investments, this one's capital.
So
you're using your money to invest in next year. Cool, right? But there's a slight little issue here. We need to, so we don't have this K0. That's why I have it green highlighted.
Okay.
So we have to approximate that K0. So the way that we do that is this is the underlying Ramsey problem, this is the underlying optimization problem. And we know what the constraint is. So we can just take the 0 with 1 and solve for K0. And it's initial investment over depreciation plus growth rate.
Oh, really?
Yep. Kind of pops out nicely.
Say it again.
Interest rate, or it's the initial investment divided by depreciation plus the growth rate.
Right.
And then R, you can either have it fixed by the model, in which case it's given by this and everything is kind of fine. Or you can tell it what R is and adjust either investment or capital. And these are the two cases. So that's exactly what I'm going through this kind of quick, I know, but that's exactly what I do here.
You do all 3 cases?
Yeah. So I set up a struct. This just has all the data. Oh, that's not the right. Dynamic data one. So this has everything that I'm going to need. And the way that you use it is you call, I have a function that returns that for each year, or for each like
period
option. Yeah.
Oh,
so this one up. This one is the first one. R equals RK0 minus the depreciation. And that's pretty much all that happens. He has a different version in GAMS that doesn't really matter anymore. It was there for testing. Dynamic data 2. So now it doesn't look like what I want it to be. Hold on, let me scroll. Oh, it's GAMS. That's why it's not what I want it to be. Dynamic data 2. 1 plus R. That's PK0. That's the definition. I shouldn't point that out. RK0, because we know R. So before we set this RK0 value by this. But if we don't know, or if we're given R, because this is how we defined R. Then we can define RK0 in terms of R. We just move this over. And then we redefine K0, and that redefines I0, and that causes an imbalance in the table because we redefined initial investment. So we also adjust consumption. Same thing here, except we adjust capital. So we have a choice. We can either fix consumption or fix capital or adjust capital. And that's what we're doing here. Here we're adjusting investment and consumption. Here we're adjusting capital and labor. And I've set this up to be relatively intelligent so that you could do something like okay, cool. So I did there's I hit the question mark.
Yeah.
And then just typed in the function name.
Is this for like posterity? So everybody knows if you type in the question mark, you in VS Code, you get help for any functions that are defined, like any packages that you already have or any functions that you've written.
Yeah, it's doing double duty because then people are like, oh, I can do that. That's cool.
Mm-hmm.
It's a teaching thing. But I can run all of these. Oh, it is right here. I just don't know where to look. It takes a second. I also have it commented out. I don't have the model displaying because it's huge. Solve it at the benchmark. Sorry, go for it.
But you suppress the print by putting the semicolon at the end of the line.
Yep. Okay, cool. I set a tax rate of 10% after 2010, just as like a little shock, nothing too horrendous. I'll do the same with D2. The same with D3. Do we expect all the solutions to be the same? I mean, you can kind of just sort of see that they're not. This is -3, this is -2. So how you're setting up this data is important. And I can hear Eli saying, how important is it?
How important is it?
There we go. Let's make some graphs. So I just made a couple data frames with this report function. You'll never guess how you determine what this report function does.
Question mark, help menu, and then find out, ask it.
Yeah.
And then because the person who wrote that function did some really helpful documentation as part of the function, it'll tell you everything.
I think so. Hold on. Let's see.
Doc
Hey,
strings.
looks like I get to eat dinner tonight. All right. Yeah, but here's comparing investment compared to the baseline, and it's a percent difference towards the reference quantity.
So
if you
the 3 cases, okay.
Yeah, the red one, hold on. The blue one right here is the one where the rate is fixed. That's the first case.
So you just set an interest rate. The growth rate is exogenous, right?
Growth rate's exogenous. We assume it's like, hold on, 2%, 3%? I don't remember. Right here, 2%.
So, and that's true in all cases.
Yep. They're all using the same static data, and the static data, oh no, that's not true. But yes, I have it defaulted to 2% in all cases.
So you've got an exogenous growth rate, and then in the fixed, you just set interest at what is the rate?
The interest rate for the first one?
Yeah.
Let's find out d1data.far. What is it? Little r? I could probably read the documentation. 8% is the depreciation rate.
Okay. It's the interest rate or the depreciation? It's the interest, right?
Depreciation. Why is it 8?
If it's R, it should be. Yeah, it says 5.
That is here. Yeah, but for this one, we're not determining it. This one is being given.
Yeah. But you,
That's interesting.
in the end, the one that you actually had in the struct was, was 1.
Interesting. So I'm matching what Ed is doing. Yeah, I'll have to check that out. Interesting.
Your
And
assumption would be that they would be the same, or what?
no, they should be different.
Yeah, all different.
Yeah, these two can be the same. That's fine. For the first one, we're not specifying the interest rate. That's the big difference.
Which one is which? So is D3 the fixed rate?
Uh,
We don't know.
D1 is the fixed rate.
D1 is the fixed rate.
Yep, I could actually just look right here. DF1 is fixed rate.
Right.
That would be smart, right?
It's one way to do it.
This is where you adjust investment. This is where you adjust capital.
So 3 is capital.
Yeah.
Okay, so we've got the fixed rate, and that's what that looks like relative to the baseline. And it starts at the first year is already had the interest rate built in. So that is at 0.8 or 0.08 or whatever that
Yeah.
is. Wait, that's not true, right? Because the other ones are 5% and they don't start at 5.
Yeah, this is initial investment.
Okay.
Yeah. So in particular, they'll be different because the interest rates are different, and these two will be different because we're adjusting the capital. And then let's see, we also have output. So you can see how output changes, consumption, capital. And I know what you're thinking. You moved through those too quickly. I couldn't see them. That's because I did this. There, I have a little button.
Okay.
So once the tax hits, consumption goes way up relative to the benchmark, and then it falls back down to where it probably should be.
The tax, because because the revenues shift.
Yeah, the revenues are going back to the consumer, so their income goes up.
Immediately. And because growth is exogenous, then it's not affected.
Or we have a bunch of water treatment stuff
So
right
not
next to my
affected.
study. That just, it's doing something right now.
Yeah, I've got a lot of roadworks right outside my place.
I was going to say the joys of living in the middle of nowhere, but you have the joys of the city as well.
Yeah, they're doing combination. They pulled a tree out and they're doing like water mains. There's a big puddle, it looks like, down there right now.
Cool.
What's going on? Okay, this is interesting. And then yeah, what else you got?
All right.
Yeah, wanted to point to that. I'm interested in sort of thinking through some of the aspects of it.
So I like, I'll say this for posterity for the recording. This graph right here, you can export it as an HTML.
Right.
And then just use it in a website. It'll just work.
Nice.
Very cool.
Is that
okay? So let's see here. Yeah. Which is not the preferred.
Buttons, that's just the buttons are a Plotly function.
Right here. So this is what's defining the buttons.
Yeah, yeah.
Yeah. Not hard, it's just very programmy.
Yeah. Plotly's got a lot of great functionality. It's a bit annoying to get the plots out as a flat file, but not that bad.
Yeah. I did that in the blog post last week. I put some graphs up there. Okay, so those two models, or those three models, there was only one output, right? We used aggregated output. What if we have sectors?
There's one sector.
Now we're going to have two sectors with aggregated output.
So you're saying we got X1 and X2 as our two sectors, and then overall output being
The Y.
then okay.
Yeah, so this, you do essentially the exact same process. The problem is that you get K0 and KS0, and you need to disaggregate LD and KD. But you have the aggregate KS. So the question becomes, how do you distribute these? One option is equal shares. Oh, my legs around. You could do, because you'll have the new KS0 right there, so you could do it that way. What Ed recommended was just a simple least squares. Nothing too horrible here. Just you don't want it to vary too much. I'm trying to find KD bar.
So
and you
this
just
is
have everything sort of match up. Sorry.
So that equation is per period T, or
No, because
that's
it's
just
just
for the initial. This is just for the
you just
initial.
need the initial. Because the future ones are going to grow, as we've already said.
Interesting.
So then here's the question. What if we have a non-constant growth rate? So this is where it gets a little bit fun. Excuse me. Let's see here. What's the model? Dynamic index model. There it is. Okay, so we're going to calibrate. We're going to go through this in 3 steps. I'm going to close my plots. The first thing we're going to do is initialize our data, set up our model, and ensure it's calibrated. And it takes a second.
It's 100 years.
It should only take like 98 years. No, it's a joke. Oh, that's a bad joke. This is the most social interaction I get all week, so I have to get all my dad humor out. Okay, so model's calibrated. Awesome. So this model's a little bit different. Here, let me show you what's going on here. This model's kind of interesting. So you can already see we have some auxiliary variables. We have TCAP, that's just pinning the tail on the donkey, so to speak, the tail. That's fine.
So terminal
SK,
capital, that's the level of capital at the last year, whatever we want.
Yep. Hence the pin the tail on the donkey.
SK is what?
So SK, right here, that's an ad valorem subsidy, or it's just a tax. So the where it comes in is right here. So we have an auxiliary variable that's a tax.
Interesting.
Yeah, I think this is actually really cool. And then we have another thing that just tracks the effects generated by paying SK. Because the payments, this tax has to go somewhere, so we want to track that in the future.
Right. Is this one of those things? Okay.
No, go for you ask, yeah.
No, is this similar to the spillover model that Tom did the other, few months ago, and then we have where you have to, it's like an externality, and then
Yeah,
you can't just put that in GAMS, and maybe you could do that differently here.
yeah, it's something like that. And we can kind of simplify it a little bit, which is nice. In fact, I could probably, where does this go in? It's all right to have it like that. Okay. Yeah, because this thing is, all it does is it appears there. And let's look at this. So SK, all we're doing is we're saying that this X gets pinned to whatever this QRefJ is. And what that is, that's just a parameter that initializes to QRef. So if SK is 0, that's allowed to float around and be whatever it wants. If SK is non-zero, those things have to be fixed. So basically what it's doing is it's saying if these two are equal, that means there's some tax being applied, and that tax is going to be the difference. Or the subsidy is going to be the difference. That's the idea. And then again, this is just tracking. That's just the tax revenue, like tracking where it goes. So that is the first thing that we do here. So the first thing that I do, I define the growth rates. So these are the new growth rates, sectoral QREFs. So if I look at set QREF, you'll see they're going up differently. Because this one goes up by 2%, this is 2.2, and then 1.6. And where it comes up is right here. I don't want this to get too negative. And then I set the value of that parameter to be this. So that changes the bounds on X. So that changes what X can be. So it's fixing it to these new values. Then I solve it, and it's done. Then we have another parameter phi. And let me do this and this. So what that phi does, it appears right here. It's essentially overriding SK in a way. So it's adjusting those by whatever that tax value was. So we found an optimal tax level, and then we sort of store it so we can keep using them all. And then we're out of equilibrium. That's expected. Saving the benchmark values. Now I'm just going to do that same shock as before after 2010. Then do some data stuff. Why is that taking a while? It's not that big. Cool. Wait a second. Did I? Oh no, it's all there. There we go. Value should not be value. That should say difference. Yeah. But yeah, then I have all of the sectors. So like A, the red and blue line track pretty well. One is with the shock, blue is with the benchmark. Red is with the shock. Not a lot of difference between those two, but B, you'd expect much more of a difference. So they get pretty far apart. Ugh. And this is tracking with the tax and without the tax, based on like reference quantities that we're giving it.
Yeah, I think that all the stuff that you've read, like you've implemented something that has a lot of intuition behind it. That
yeah, you kind of gotta
would take a really long time to kind of go, but it also is sort of the main part that I'm interested in.
Yeah. Like the MPSGE, like what the heck is happening?
No, like the actual economics of why you're setting up the various sort of elements in those ways and what you're saying about it. But yeah, exactly. It's all there.
Yeah, Ed has these notes. That's essentially what I'm using. This right here is what I'm talking about. I will say a lot of what I did is I took what he was doing.
Yeah.
And I made it so it actually corresponded to what was in here.
As opposed to the GAMS where it was slightly different, maybe.
Yeah, he defines R differently. So here he defines it like this. Sort of like he has this extra term on the bottom. The numbers are exactly the same.
Yeah, so I think that what's happening here for me is that you've implemented his set of examples and have shown like a really neat way that MPSGE can run those, put out these great outputs, these really nice interpretive plots that are you can adjust and all very efficient and clean. And then for the background on like what the question is and why it's relevant, that's all sort of back in the notes of the models that he set up in the first place.
Yeah, pretty much how it goes. But I think the big thing is showing an example that, like, I haven't necessarily seen something like that exactly before. Like what Tom would usually have me just not doing much. It's too bad.
Is it still recording?
Yeah, should I kill the recorder?
I don't know. It depends if you wanted anything else for reference.
Oh, already got it.